4.1, divisibility. So we are extending some of our ideas in this section from the last chapter. We're still working with whole numbers, but we're continuing with what we were working on with dividing numbers when we get to here. All right, so to start with, we're going to define the word divides. If A and D are whole numbers, then we say that D divides A. Notice the notation. The D comes before the A, and it has a vertical line segment. Vertical. So D divides A if and only if there is a unique whole number Q such that A is equal to DQ. Like Dairy Queen. Maybe we'll stop at one of those on my trip. That sounds exciting. Okay. If D divides A, then we actually call D a factor or a divisor of A. And we also call A a multiple of D. And as with any definition, putting some numbers in makes it a lot more clear as to what we're talking about. So we would say that 4 divides 20. And the reason is because 4 times 5, there's a number 5, specifically this is the number, that equals the 20. And this right here is that Q that it's talking about. There's a number, there's a Q that I can multiply, in this case by 4, to get to 20. So what we would say then is that 4 is a factor or divisor of 20. Shake your head because you know that's how we talk. We use that language, right? And we would also say that that makes 20 a multiple of 4. And one of the ways that I like to help students keep track of which is which, because sometimes people confuse the words factor and multiple or divisor and multiple. They just switch them in their minds. Multiples are in the multiplication lists. Like if you think about my multiplication tables, what are my multiplication tables or my multiples of 4? 4, 8, 12, 16, 20. Those are the multiples of 4 because they're in the multiplication list if I were to write out all of the lists of 4 times 1, 4 times 2, 4 times 3, and so forth. Okay? There's a very nice theorem that comes next that's kind of interesting. It says, if we have whole numbers A and D divides A, and N is any whole number, then D will divide N times A as well. So this is saying, because 4 divides 20, like the last example I just did, 4 is going to divide all multiples of 20. So think about taking 20 times something else. 20 times 5. It's random, right? Or 20 times 7. We'll do 7, even that's even worse, just because it's like not the, I got 5 on the last screen, so I didn't mean to use 5 again. 20 times 7. Right. So I'm also guaranteed that 4 is going to divide the 20 times 7, which Valerie told me, and she's right, is 140. It has to. So all multiples of 20 are also going to be divisible by 4. There are 5 very cool divisibility rules that we're about to hit next, and I get to write all of them down just like you do. Are you ready? Because you got like lots of blank space, don't you? Yes. Yeah, me too. Look at my blank space. All right, so for any whole numbers, A, B, and D, if D divides A and D divides B, then D divides A plus B. So let me just use an example as we go with even numbers. If 2 divides 4 and 2 divides 10, 2 will divide 4 plus 10. If 3 divides 12 and 3 divides 15, 3 will divide 12 plus 15. Okay, and from a fractional standpoint, you guys know this to be true. Let me use that one I just did as an example. So 3 divides 12, right? This would be a whole number. And 3 divides 15 was the other one I did. And if I write this as 12 plus 15, I don't know why I wrote an equal sign there. That's not real helpful. So if I were to write 12 plus 15 here, even without actually adding the 12 and the 15 together, I can verify that this has to work. Just from a standpoint of fractions, I can divide all pieces by 3, right? So this is a divisibility operation. This would be 4, this would be 5, and this would be 1, and it'd be totally good to go. I'd end up with a whole number on top. Okay, and that works always when you have this divisibility rule. Okay, so let's take a look at another one then. All right, let's do one that says if D divides A, and now D does not divide B. So I didn't introduce this notation, but we've talked about this idea before, that when we take something that has a meaning and we put a slash through it, it means the opposite, right? We do it with not equals, we did it with not an element of, and now we're doing it with not dividing. Put a slash through it, it doesn't divide. So D divides A, D does not divide B. What would you expect to happen when we compare D to A plus B? We're adding this. So is it going to divide or not divide? No. It's not going to divide. No, it's not going to divide. And again, we can use the same kind of an example, right? So 3 divides 12. 3 does not divide 10. And if I were to try, even if I don't add the 12 and the 10 together, there's no way to reduce that 3 with both pieces, the 12 and the 10 on top, right? You can't do that. It's not going to divide it because it fails to divide just one piece of it. It's going to fail to divide the sum. Okay, now we're going to do subtraction. Valerie, you were actually spot on where I was headed. So we're going to take a look at what happens with subtraction. If D divides A and D divides B, and I'm going to work with A being greater than or equal to B just because I'm only working with positive numbers, right? I'm not working with negatives and integers yet. That's chapter 5. But if that happens, then D divides A minus B. Okay, so subtraction works. And it actually works whether or not A is bigger or not. We're just not talking about negative numbers right now. We're only talking about positive numbers, so that's the reason that caveat is in there, or that disclaimer or condition. So again, right, if 3 divides 12 and 3 divides, I did 15 before, and whichever one's bigger, it doesn't really matter right now, the 15 minus 12 will be divisible by 3. And again, we know that to be true whether or not we actually do the subtraction, because 3 is a divisibility piece. It's all in all pieces, right? So going with what I just did a minute ago, we're still going to have D divides A, and now we're going to have D does not divide B. And A is greater than or equal to B. Then D does not divide A minus B. For the same reason. There's going to be one piece of it that doesn't work. And because I'm worrying about the order so that the subtraction is positive, I get this second one. These are really like the same piece. They got to have to be both written down because it doesn't really matter what order the does not divide occurs in. So it could be that D does not divide A, but it divides B. So these last two are sort of like they go hand in hand. It's just saying it divides one of them and not the other, and it doesn't really matter which. The rest of the pieces are all mirroring the same way. So then D does not divide A minus B, just like, sort of like bullet number 4. Notice what this doesn't include. Look at all my conditions at the beginning. Doesn't talk anything about multiplication and division. And the reason it doesn't is because we have this other interesting multiplication thing over here, right? If you divide something, then the multiples are all getting divided. What else does it not include? Well, we're not working with fractions, that's true. Take a look at the conditions. That's what I'm trying to get you to see. Like the order switching, true. I'm not switching my order. I want to keep the pieces in the same order to make the comparisons. The negatives are going to come when we get into chapter 5. What do you mean?
Like, never mind. Like in the first example, like you're like 4 times 5 equals 25 is the cube. There's no.
Okay, but there is understood to be one in it. Otherwise, the division wouldn't work. But you're kind of getting along the right track on that. So if you take a look at this one, Emma, do you see how we'll say it's lines? I need a highlighter. Let me see here. Do you see how this and this match? They both say D divides both of them, right? I mean, they sort of go together. D divides both, the D divides the sum, D divides the difference. That's great. So, nope. It's okay. Here, here, and here. What do they all three have in common? The negation pieces is what you're thinking of. How many do they have, though, Emma? 1. They all say what happens when one of them fails to divide. What do they not say? What happens when they both fail to divide? What happens? Well, it's in your homework. You'll get to it. But that's what's not included here. It doesn't tell you what happens when both of them fail to divide. Like, what happens if D doesn't divide A and D doesn't divide B? Does that mean it's not going to divide their sum? Does it mean it's not going to divide their difference? Or does it mean it will? And the answer to all of those is yes, it does. It does sometimes, and it doesn't sometimes. So you're going to explore some of those conditions that look like that. When does it actually end up working and when does it not? But notice, there's nothing that's said about that here, right? It doesn't talk about that potential possibility. And the reason it doesn't is because it's conditional upon what problem you're working with. Sometimes it will, sometimes it won't. And you're going to look at examples and counterexamples to that idea. All right, the next pieces that we're going to take a look at with divisibility don't talk in general. So everything we've talked about so far is generalities of how divisibility works. What we're about to do is specific tests to see when numbers divide others. Okay? So your first 3 right here. It says divisibility test for 2, divisibility test for 5, divisibility test for 10. These are all on the same slide because their divisibility tests are all very similar. I already switched to my next slide, so we'll see how closely you guys were looking to know how to fill things in, because that's not what I meant to do. Okay. How do you know if a number is divisible by 2? Okay, say that really loud, Kaylin. Okay, and the key word she said was the word ends. Okay? A lot of times we hear, and that may have been what you were saying, Valerie, I wasn't listening closely, but a lot of people want to say, well, if it's even. Well, what does it mean to be even? Well, it really means that the last digit, the ending value is even, right? Okay? So don't write anything down yet, but that's true. That's what it is. How do we know if a number is divisible by 5? Has to end in a 5 or a 0. And how do we know if a number is divisible by 10? Has to end in a 10, or end in a 0 to make it divisible by 10. I said it wrong, yeah. Okay, so these 3 rules are sort of grouped together because they're all talking about the ending digit. It's all about the last digit. So a number is divisible by 2 if and only if the unit digit is even. Divisible by 5 if and only if the unit digit is 0 or 5. And divisible by 10 if and only if the unit digit is 0. Those are the probably the most common 3 divisibility rules. If I gave you like all of the divisibility rules at once, these are the 3 you'd most likely chalk off and say, yep, I think I've seen that one before, or I know that one, or I already would have known that one. The next 2 are not so common. People don't tend to always learn these 2, and they're very practical. At least the divisibility by 4 one is. Maybe not as practical for the divisibility by 8. But they're grouped together because they're similar as well. So I'm going to flip the screen. I'm going to read them, and you're going to write them, and then we'll talk about them. Divisibility by 4 happens if and only if the last 2 digits value as a 2-digit number is divisible by 4. And divisibility by 8 is that the last 3 digits value as a 3-digit number is divisible by 8. Okay, so somebody give me 6 numbers in a row. They don't even have, they can duplicate, they cannot duplicate, I don't care. Just give me 6 numbers.
4, 8, 3, 9, 2, 1.
Okay, everybody good with that? They didn't even duplicate. Look at that, Valerie, good job. Okay, I'm going to do both of these. What these properties are saying is that if I want to know if a number is divisible by 4, all I have to do is look at 21. Does 21 divide by 4? No, so neither will this long value. And if I'm looking for divisibility by 8, I look at the last 3 digits, 921. Does 921 divided by 8? It's not. You get this one kind of for free because you happen to pick an odd number for me, and odd numbers are never going to be divisible by even numbers. But if you weren't sure, and you even had to work it out by hand, it would still be easier to work out by hand 921 divided by 8 to check than 483,921 to check. Agreed? Yeah, it would. It would be less work because there's just 3 digits. So that's what these rules are saying. So, and in some ways, this connects back to the divisibility rule by 2. The divisibility rule by 2 says that I really only have to look at the last digit, right? 1 digit to see if it's divisible by 2, 2 digits to see if it's divisible by 4, and 3 digits to see if it's divisible by 8. That's not coincidence. It's happening on purpose. Okay? So that's divisibility rules for 4 and 8. Let's try another one. Oh, before I switch it, has anybody heard the divisibility rule by 3s before? Usually that one's one that some people have heard. Valerie, do you remember it?
Mm-hmm.
What is it?
If you add them in, add the number and it's divisible by 3, then it's
Divisible by 3.
Yeah.
Okay, can you add to what she just said, Danielle?
I thought it was just the last 2.
It's not the last 2. That's a good guess because there is one here that's about the last 2 digits. So what Valerie's saying, and let me expand on it just a little bit, is that if you take all the individual digits like this number, and you were to add 4 plus 8 plus 3 plus 9 plus 2 plus 1, if you were to add them all together, whatever that sum is, if it divides by 3, then the original number divides by 3 as well. My daughter was practicing last night for the pre-PSAT. That's the one she took today at school. What a story to start fall break, right? PSAT, here we come. So she was doing that last night, and she actually did this rule. She had a 2-digit number, so it wasn't very big. But she had a 2-digit number. We'll just make something up because I don't remember what the number was. Let's say it's 48. And she was like, I don't remember if that's divisible by 3 or not. It was kind of big. Well, so what she did is she said, okay, well, 4 plus 8. 4 plus 8 is 12. 12 divides by 3, so I know 48 divides by 3. Okay? So, and you can do it with however many digits you have. The cool thing is that rule is not just a rule for 3. It's actually a rule for 9 as well. So if you add all the numbers together and it's divisible by 9, then the original number was divisible by 9. So these 2 are grouped together, 3s and 9s.
Just the number that I
Is it? The one you picked was divisible by 3. Fantastic.
Divisible by 3.
Emma.
I want to ask a question, but I don't exactly know how to phrase this question. So you said like 2, 4, and 8. Is it because their powers are like opposed?
Yes, that's exactly what it is.
That's the same reason for that. It's because of power.
Yes. That's exactly right. Good observations. These are great steps that are check steps for kids. Right? So if my kid is doing division and they're in 4th or 5th grade and they're getting a remainder of 7 and I'm like, I don't think there should be a remainder on the problem, and they're dividing by something that's easy to tell if you've got some divisibility rules, either you as the teacher can let them know, hey, that's not going to work or that is going to work, even if you don't explain to them why, you just know whether they're right or wrong, or you can use it as a way to help them recognize the validity of their answers. Are they right or wrong? What do they expect to have happen? Because they have some divisibility concepts underneath their belt. Okay, maybe you don't do all of these numbers, but maybe you do some of these ideas, right? I don't feel like that there's any 4th or 5th grader, I should probably check between my 5th graders to be sure this is true, who should ever not know that if a number's not even, it's not going to divide by 2. I think they should know that rule. Right? I think they should know when a number is divisible by 2 or not. They should know when a number is divisible by 10 or not. There are some of these that are just very concrete, simple ways to check. Okay? That said, the next one is not one of those. It's messy to write down. So first I'm going to have you write down what's on my screen, and then I'll show you how it works, and you'll be like, oh, that's what it was trying to say? But I don't know any other better way of writing this, so we're just going to write what we got. Don't write down the divisibility test for 6 just yet. We're just going to talk about the 11 for now. A whole number is divisible by 11 if and only if the sum of the digits of the places of even powers of 10 minus the sum of the digits in the places of odd powers of 10 is divisible by 11. It's terrible sounding. I'm grabbing Valerie's example again that she gave us so that you can see what this is saying. What this is saying is that I take every other digit, 4, 3, 2. And then I've got 8, 9, 1. So everything I've circled in red, if I were to add it together, 7, 8, 9, I get 9. Everything marked in blue, if I were to add it together, I get 18. Wow, that 18 is terrible. I can't do that. I'll use a darker blue anyway. Okay, is everybody good so far? Did I add my values right? Are we good? Okay, all this rule is saying is that I choose every other number. And then I subtract these two sums. So if I were to subtract 18 and 9, what would I get? 9 or negative 9, and I don't even care, but it's fine. 9 is the difference, right? Is 9 divisible by 11? Then neither is the Valerie number. Neither is the Valerie number. That's right. All right, it's not going to work. Now, let's say, for instance, that I changed it just a little bit. Let's say this last digit she gave me really wasn't a 1, and it was a 3. I think I need a 4. What do I get when I add 8 plus 9 plus 4? Is that big enough? Did I need a 3? I think I needed a 3. I'm trying to make it work.
20.
How about 3? 3 is 20, right?
Yeah.
Okay, 20 is what I want. 20. What's the difference now between 9 and 20? 11. Is 11 divisible by 11?
Yeah.
You betcha. It is. So this number now that I changed it to would be divisible by 11. Something that happens in one of the problems in your book that confuses people in this one is one where I end up with the same number. Like, let's say I did this sum and I ended up with 9 and 9 in both of them. What's 9 minus 9? 0. Okay, 0 divided by 11 is 0. Yes, so it would work. Kind of works by default. It's like you get it for free, but it's sort of uninteresting, right? But it works. So even if they are the same number, you subtract them, you get 0, it's going to work. So you need it to be 0 or 11 or 22 or 33. That's what you're looking for on this. Okay, divisibility rule by 6 is an interesting one because it has application far beyond just looking at the number 6. The divisibility rule for 6 says that a number is divisible by 6 if and only if it is divisible by both 2 and 3. So, why do you think that the 2 and the 3 are the right numbers to check for divisibility by? Because 2 times 3 is equal to 6. It's exactly right. So the reason that this works is because the 6 is 2 times 3. But I'd like to pause here for just a moment to recognize that it doesn't always work for any breakdown of numbers. So I'm going to flip to my last screen up here. Okay, so we're going to do an exercise real quick in examples and non-examples of this working. So let me show you what I mean. We just have an example. So I can check for divisibility by 6 by checking 2 and 3. Okay? Another example that would work. I can check for divisibility by 15 by checking 3 and 5. Okay? I could check for divisibility by 30 by checking 3 and 10. Okay, and so by now you're probably like, yeah, Dr. Hands, you just broke them down into factors. What's the point? So bear with me. I could actually do 30 in another way too. I could do 30 as 5 and 6. So let me give you some non-examples. I cannot check for divisibility by 8 by checking only 4 and 2. I cannot check for divisibility by 4 by checking 2 and 2. I cannot check for divisibility by 24 by checking 6 and 2 and 6 is what I wanted. 2 and, I'll do 2 and 12. There we go. But I could test for divisibility by 24 by doing 3 and 8. I cannot do divisibility by 12 by doing 2 and 6. That's what I was trying to do just a minute ago. But I could do divisibility by 12 by doing 3 and 4. Okay, so in every single case, the two numbers on the right-hand side multiply to be the bigger number, right? Like that's why I picked them. I mean, obviously why I picked them. So what is it about the examples that works that's different than the non-examples that fail?
There's at least one odd number.
That may be true, but I'll example that won't. So let's see. How about I do 63, 7 and 9. I got 2 odd numbers now. That one didn't work. I think that's what you were telling me. Is that right?
Yeah.
Okay. Oh, I did. So maybe I need to give you an example of one that doesn't.
Yeah.
So non-examples over here. How about 27? I cannot do 9 and 3. Those are both odd, right?
Mm-hmm.
Okay.
What I'm saying is that for the examples that do work, there's at least one odd number.
For the examples that do work, there's at least one odd number. That would be true.
I feel like it doesn't mean anything though.
But I mean, I've got an odd number I just gave you on the 27, and it's not working in force, right? So that's not good. Okay, keep looking. The key is the relationship between these numbers when you consider them as pairs, compared to the relationship between these numbers considered as pairs. What is true about one set, one side of my screen, that's not true about the other? Do you have an idea, Annika?
In the non-examples, one of the numbers is a factor of the other.
It is, and you're on the right track, except that I could do 24 is 6 times 4, and it wouldn't work either. But you're really close. Did everyone understand what Annika was saying until I got to there? Emily's got her hands up, but I don't think she wants to talk to me.
Oh, no, sorry.
Yeah. The numbers on the right-hand side, all as considered in pairs, when you put them in pairs, not all the whole list, but in pairs. Each pair has a common divisor. Right here. Whoa, that was still my highlighter. These are both divisible by 2. This one's both divisible by 2. By 2. This is what Valerie thought I was doing. These are both divisible by 3. These are both divisible by 2. But do you see that my other list doesn't have that? There's nothing, when I consider the two of them at a time, that divide both pieces. And we're going to encounter a phrase for what happens that just a phrase that describes that relationship later on. But for now, we're just going to talk about the fact that they don't have anything in common as a divisor. So if you wanted to test for divisibility by 20, what are two numbers that you could test instead of just trying to divide by 20? 4 and 5 would work. What are two numbers that you would test that would not be appropriate? 2 and 10, because they have a common divisor of 2. Do you guys see? The relationship matters. Okay, so that is sort of the place where that property or that theorem leads us to in terms of other numbers. So what we're going to do on example number 1 is we're going to take this number, 24,015, and we're going to check and see if it's divisible by a collection of numbers, namely the numbers in which I have these properties, these rules, these theorems. So we're just going to go down our list. And in your book, there are places where it just says to decide if it's divisible or not. And that's fine. If that's all it says, you don't have to justify it. But I will guarantee you that when we get to a test, I'll ask you why. You won't just be able to say yeses or nos. So it's a good idea, and we're going to do in class justifying our answer as to the yeses or nos. So 2. Is 24,015 divisible by 2? No. Why not? Right. No, because it doesn't end in an even. How about 3? It's yes. Why? It's not the last two. Be careful. Okay, so let's add the digits. We have 2 plus 4 plus 0 plus 1 plus 5, and you said that's 12. Is that right?
Yes.
Is 12. So the sum is 12. And to get us familiar with the notation, 3 divides 12. So 3 divides 24,015. Does that make sense? Cool. How about 4? No. Why?
It was 6, it's not divisible by
Okay. You've added things together, though, and that's not the rule.
times
Nope.
3.
Yeah. Okay, so the last two digits is a 15. We take it all together. We don't multiply or add or anything. It's just 15. And we know that 4 does not divide 15. So 4 does not divide 24,015. about 5?
Yes.
Yes, why?
It ends in 5.
Yeah, because it ends in 5. Lovely. 6.
No. Because it's not divisible by 2 and 3.
Right, because it, even though it's divisible by 3, it doesn't divide by 2 exactly. How about 8? Yeah, this one happens to have a 0 in the hundredths place, so the 015 is the 3-digit number at the end, and 015 or 15 is not divisible by 8. 8 does not divide 015, so 8 does not divide 24,015 either. How about 9? Not quite. Back of the divisibility test by 9.
It's 12. Still no, it doesn't.
Okay, so the sum, basically what we had before was 12, right? 12 divides by 3, so it makes divisible by 3. But the 9 does not divide 12, right? So 9 does not divide 24,015. How about 10, right? No, because it doesn't end in 0. And 11. Okay, so let's run through the 11 test too again. So this is, 24,015. So every other digit, 2, 0, 5. What are the blue ones?
7.
Okay, and then I'll do red. 4 and 1 are 5. And what's the difference here? The difference is 2. 11 does not divide 2. So 11 does not divide 24,015. Does that make sense? All right, so we're going to look at some true-false kind of questions and yes-no kind of questions over the next couple of examples, and I think that'll put us at the end of class. So the first one here, example number 2, says that we're going to classify each of the following as true or false. Now, we'll talk about the why. Again, if we were actually doing problems that I asked you on a test, I want to know that you know the why behind it, not just that you're really good at guessing something that's 50% in your favor, right? That's not the goal. So it says, if a number is divisible by 6, then it is divisible by 2 and 3. That is true. And that always works. No, not just because it's 6, 2, and 3, but because 2 times 3 is 6. I mean, that will always work. So that's good. If a number is divisible by 2 and 3, then it's divisible by 6. Yep, that's also true. And in fact, if you take a look back at our divisibility rule of 6, that's what the if and only if phrase in the middle means. It means that you can start on the left and say the statement, like with the if at the beginning of the left piece. If a number is divisible by 6, then it's divisible by 2 and 3. And since it says if and only if, you can put the if on the right-hand side. If a number is divisible by 2 and 3, then it's divisible by 6. Okay, that's what if and only if means. It means it goes both directions. So we get these both as true. Now, C and D are more along the lines of my example, non-example that I showed you otherwise, right? So let's take a look at that one. It says if a number is divisible by 8, then it's divisible by 2 and 4. So let's think about our divisibility rules. When is a number divisible by 8? When the last 3 digits are divisible by 8, right? Well, if the last 3 digits are divisible by 8, it automatically means it's divisible by 2. It has to be even, right? So you get the 2 for free. And the reality is that it also works for the 4. And the reason it does is because 8 breaks down into 2 and 4. So if you're going in this direction with the bigger number, right, the product number, and you're breaking it down into its factors, it'll always work. If a number is divisible by 15, it's divisible by 5 and 3. If a number is divisible by 100, it's divisible by 4 and 25. If a number is divisible by 63, it's divisible by 7 and 9. Always works when you start with the bigger number and move into the smaller factors. What doesn't always work is the next one. If a number is divisible by 2 and 4, then it's divisible by 8. That is not always true. Can you give me a number that's divisible by 2 and 4, but it's not divisible by 8? 4. 4 works, actually, yeah, it does. 4 is divisible by 2, 4 is divisible by 4, and 4 is not divisible by 8. It's the smallest one. You got it. This is false. Right, so 4 is divisible by 4. 4 divides 4, and 2 divides 4, but 8 does not divide 4. And it's not the only number. How about 12? Right? Yeah, 2 divides 12, 4 divides 12, 8 doesn't divide 12. Okay, and the reason it doesn't is because it's in that non-example list. And it's because it has factors that are already duplicating themselves. I get too much stuff. When I don't have factors in common, like if I were looking at the number 15, and I were saying, oh, look, I can just look at 5 and 3. That's fine, because the multiples of 5 and the multiples of 3 only intersect when they're also multiples of 15. That doesn't happen when the numbers have something in common. How about this one? We'll end our discussion with example 3, and we'll be done a tiny bit early, I think. Answer the following question without actually performing the division. Explain how you did it in each case. 34,051, is it divisible by 17? We had a strategy back in 3.5 that we could actually use to do mental math here.
Rounding.
It's pretty nice. No rounding. Rounding won't keep things exact.
Is it breaking up the dividend?
Yes, it is. So Annika, tell me what I might look at and if I'm going to use that strategy, since you thought of it.
We would break up 34,051 because we know 34,000 is divisible by 17.
Yeah. So breaking up the dividend is really helpful for values that you don't have rules for. I don't have a rule for divisibility by 17, nor do I care. I mean, like, really, it's 17, right? But if I break this apart into the 34, I could check pretty quickly that 34 is divisible by 17, right? It's 17 times 2. How about 51? Is 51 divisible by 17?
Yes.
It is. It's 3, actually, as well. And even if you're not doing it in your head, that's fine. You could add the number together multiple times or multiply by 3 pretty quickly to check it out. This one works. So it's yes. And it's because 17 divides 34, it's 2. And 17 divides 51, it's 3. So it works. So if we think along those lines, what do you think is going to happen on B?
Division again.
You can think about the dividend again. So is it a yes or no?
19, yes.
Yeah. So this one's a no. Okay? So while 19 certainly divides 19, like that's good to go, no problem. 19 does not divide 31. That's a no-go. 38 would be great, but it's not 38, it's 31. C is a fun question. Is 2 times 3 times 5 times 7 divisible by 5? Absolutely. How do you know? There's several things you could say.
It's times 5.
Yes. There's a 5 in it. Like, think about what would happen if you wrote this in fractional form. If I wrote down 2 times 3 times 5 times 7 in the numerator and I wrote 5 in the denominator, what would you guys do with the 5s? You'd mark them out, wouldn't you? You would. You'd be doing that since like middle school. That's where you learned that. This idea of canceling like terms. When you learn fractions, reducing numbers, things like that. It works. If you weren't thinking about it from that perspective, Another way you could think about it is the fact that there's a 5 in this list of numbers, right, means that this value is going to end in a 0 or a 5. It has to, because 5 is one of the factors, right? Therefore, it's going to be divisible by 5 because it ends in a 0 or a 5. So if you like that line of reasoning, that works too. So this is working. I'm going to write down the first one. That's what I have written down on my paper. Either one's fine, but it's because 5 is a factor, specifically it's listed, of 2 times 3 times 5 times 7. So then, is 2 times 3 times 5 times 7 plus 1 divisible by 5?
No,
Yeah, I see a 5 in the list. What's the problem?
because after you add, multiply, you can add that one. It's going to take it from 5 or 0 to 1 or 6.
Okay, so that's why I mentioned what I mentioned in the last problem, actually. So the reality is, we know that this number, right here before we get to the plus 1, ends in 5 or 0, right? It definitely ends in 5 or 0. And what happens when I add a 1 to that? Can it still end in 5 or 0? Nope. It's going to end in either 1 or 6, right? Is there a number I could add to the end of this that would be okay?
10, 5.
10 would work, 5 would work, 15 would work. In fact, any multiple of 5 would be okay at the end because it would still make my number end in a 0 or a 5, which is the goal in order for a number to be divisible by 5. So this one is a no because 2 times 5 times 3, I didn't put those right, 2 times 3 times 5 times 7, it actually ends in a 0, but I'll just say ends in 5, a 0 or 5. Adding 1 will make it end in 1 or 6. So it doesn't work. Any questions on that? All right, so to answer the question that was posed at the very beginning of class, Dr. Haynes, do we have homework over fall break? The answer is now. No, because we did not get finished with 4.1. I didn't think we would, but you never know. I'm awfully optimistic. It just didn't work out today.